Today's lesson in solving two-step equations from section 2.2 is really, I got two small parts that I want to demonstrate to you today. One is just the justification concept for solving an equation. What rules do we have that allow us to do the things that we're doing? Adding, subtracting, multiplying, dividing, and all those different things to an equation. So just as an example, here's our first problem that I want to kind of walk us through. To eliminate this 18 on the problem, you know by now that you're going to subtract 18 from both sides. Well, why are we allowed to do that? Well, very simply, there's four basic rules. Addition property of equality, subtraction property of equality, multiplication and division property of equality. This is the subtraction property of equality that says we're able to subtract the same thing from both sides. Whenever we are working on a problem, and we have 18 minus 18 cancels itself out, that's just called simplification. 21 minus 18 is 3. That also is simplification. Some people might say that first part was the additive inverse property that added them to 0. Now, how do we get rid of a minus sign in front of a variable? Remember, that's really minus 1n. Well, to get rid of a minus 1n, we can either multiply by -1 or divide by -1. I chose to multiply, so I did that to both sides. That's the multiplication property of equality. Then once again, when we're just working out and simplifying a problem, the next step is just simplification. So that's just an example of what it means to justify each step of an equation. Let's look now at our second example for today. Second example is involving matrices. A matrix, remember, is just a way to organize data in a very consistent and similar way. So here's our matrix. We have first about to analyze our matrix and say, are these matrices possible to be equal to each other? Well, the first one has 2 rows and 2 columns, as does the second one. So they are equal to each other. Now what we're going to do is we're going to take the first element in the top left and set that equal to the first element in the top right. So here I have my working it out, and I'm going to set these equal to each other. So let's take a look at what I've done. I've set them equal to each other, subtracted 4, got 12, and then divided by 3 and got x equals 4. Next, we're going to work and take a look at the second part. Here I said 4 equals 2a. Notice the positions that I've circled are the similar positions on the problem. So I said 4 equals 2a. To get rid of the 2 in front of the a, we divide both sides by 2 and get a equals 2. Our third part, I'm going to circle those bottom left corners. That's -3 equals m. Well, there's nothing really to solve there. I guess if you wanted to, you could put the m on the other side. And then finally, we'll underline these last two. 4y equals -20. To get rid of the 4 as a coefficient, we divide both sides by 4 and get y equals -5. So my purpose here was just to identify and illustrate justifying equations and then solving a matrix equation as two other things that might come up as we practice these types of problems involving solving two-step equations. Our homework tonight, as you can see at the bottom, is section 2.2 on page 84. I'll see you tomorrow.